Chapter 6. In Chapter 6, we're going to introduce your second kind of chemical reaction. Remember, your first kind was the metathesis reaction, where the model was AB reacting with CD to form AD and CB. Do you remember that?
Yeah, I remember it.
Okay. And what did AB and CD represent in a metathesis reaction?
They're both. AB and CD are ionic compounds in solution.
Very good. They're aqueous solutions of ionic compounds. Excellent. In an oxidation reduction reaction, and this is your second kind of reaction, it's kind of got a long name, oxidation reduction. And we can call it oxidation reduction. You could also call it reduction oxidation reaction. You could also conjunct it into where you just call it a redox reaction. A redox reaction, where you get your reduction portion and your oxidation all in one word. Redox.
Redox.
Yeah, good. Oxidation is the step in which an electron is lost. Reduction is the step in which an electron is gained. And in an oxidation reaction, what's occurring is electrons are being transferred from one species to another. Okay? Our classic example is the combination of sodium with chlorine to form sodium chloride. So sodium, if we bring up our periodic table, we can see that sodium wants to, what does sodium do to stabilize itself?
Let's see, it has 11 electrons and neon has 10. It needs to lose an electron to have the same number as a noble gas.
That's right. So sodium would like to lose an electron, whereas chlorine would like to do what?
Gain an electron.
Very good. And so when this process occurs, we say that sodium is oxidized. That's our fancy word for loses an electron. And chlorine gains an electron or is reduced. Okay? Now, in this redox reaction, it all happens underneath the cloak of a chemical reaction. And sometimes it's hard to see. You can't tell who's gained and who's lost an electron. We'll start off with easy ones where we have a way to tell, but gradually we have to kind of develop an understanding of how you can tell who has gained and who has lost an electron. We do have ways to write what we call half reactions, though, to kind of think about just half of what's going on. So, for example, an oxidation half reaction just shows the element, in this case sodium, losing an electron, becoming a positively charged ion and losing that electron. We can show chlorine gaining an electron. Now, there are two chlorines in chlorine gas, and so there's 2 electrons gained and 2 chloride ions result. Okay? And if you take your oxidative half reaction and your reductive half reaction and add them together, then you get the net redox reaction. Okay? They have to always occur together. So you can never have just an oxidation half reaction or a reductive half reaction occurring. They always have to occur together. Okay. When we have an oxidation or a redox reaction occurring, then one substance is oxidized and the other is reduced. And we say that the substance that is being reduced, for example, is the oxidizing agent because it was reduced, but that means that it oxidized the species that it was reduced by. Okay? And in the same way, we say that the species that was oxidized, sodium atom here, is going to be oxidized. It is the reducing agent. Okay? Because if sodium is being oxidized, that means it has to do what with its electrons?
Lose an electron.
That's right. And it doesn't just have to lose it, it has to give it to some other species. And so if sodium is giving that electron to chlorine, we say sodium is the reducing agent. The reducing agent. Chlorine took those electrons from sodium, and so we call it the oxidizing agent. Okay? So another way to think about it is the chemical that's reduced was the oxidizing agent. The chemical that was oxidized is the reducing agent. Okay. And this is helpful because sometimes you want to speak about which chemical is being oxidized, but sometimes you want to talk about which chemical is is doing the oxidation or which chemical is doing the reduction or is being reduced. Okay, so here's a chemical reaction. We have zinc and platinum ions reacting together, and the product here is platinum metal and zinc ions. Okay, so zinc went from no charge to a +2 charge. What do you think? Does that mean it gained or lost electrons?
+2 electrons?
No. Remember, what does that +2 charge mean?
Oh, yeah. It lost 2 electrons. That's why it has a net +2 charge.
Very good. So if zinc lost electrons, was zinc here oxidized or reduced?
Zinc was oxidized. Oxidation is loss.
Very good. Now, how did you remember that?
You just showed us it on the previous slide.
Okay, very good. But there's going to be a need to remember that for a longer period of time. So I'm going to introduce to you some methods that we sometimes use in chemistry to remind ourselves that oxidation is loss. It's a little mnemonic device. That says oil, right? Reduction is gain. So oil rig, the little phrase there, oil rig, helps us remember that oxidation is loss of electrons and reduction is gain. And there's another one called Leo, the lion, says GR. And this stands for loss of electrons, oxidation, gain of electrons, reduction. All right. So these are, you can choose any one of those, or if you think you could just remember for the rest of your life, that's all right. But we do need to be able to know that oxidation is loss of electrons and reduction is gain of electrons. Okay? So, zinc was oxidized. Does that mean platinum had to be reduced?
I don't know if it has to be, but I can see that it is.
Okay. And it does mean that it has to be, unless there was another zinc product over here. But because there's only one product, that means that the platinum ion is reduced to platinum metal. Okay? Now, which species function as the oxidizing agent? You remember how you can tell the oxidizing agent?
You said that the oxidizing agent was the thing that was reduced or that did the oxidation.
Right, which is basically the same thing. So, who was oxidized?
Zinc was.
Who did that? Who caused that oxidation?
The platinum ion.
Very good. So C is our oxidizing agent because it caused the oxidation, or you can think of it as it was reduced, therefore it's the oxidizing agent. Okay, very good. Here's another one. Try this one at home, and then we'll work on it together. Okay, did you try it? Okay, hope so.
I know how to do it. Silver is being reduced, so which species gets oxidized? Zinc metal, so that's D.
Very good. Zinc metal is being oxidized. And the way you can tell, again, is because here, how many protons does this species have? Right there.
Can I see the periodic table?
Sure. You can look at zinc there.
30.
Yeah, zinc has 30 protons. How many electrons does this species have?
30.
How about here? How many protons?
28.
How many protons, not electrons?
Oh, yeah, 30 protons, so still the same.
That's right. And what's 28, or what's this +2 mean?
Oh, 28 electrons.
That's right, 28 electrons. So it has lost 2 electrons through this process. So that's how we knew that it was, it's been reduced, and therefore the silver ion was oxidized. It was been oxidized. It lost 2 electrons. So that's, zinc is been oxidized. Okay. Which of the following species is the oxidizing agent and which gets reduced? Okay, make sure you work on it at home before you move forward. What do you think, Fred?
Isn't the species that's oxidized the same as the one that gets reduced?
That's right, it is. So our oxidizing species is also the one that's, our oxidizing agent is also the one that's going to be reduced. Which one's easy to pick out here for you?
The Mn. What's Mn?
Manganese.
Manganese. Manganese is being oxidized.
Very good. So that means the oxidizing agent is what?
The H+ ion. So the H plus ion is the oxidizing agent, and it was reduced.
Okay, which answer is that?
B.
Very good. Excellent job. Okay,